Hey guys, welcome back to the channel. In the last lecture, we've seen various text pre-processing techniques that can be used in any kind of NLP projects. In today's lecture, we are going to look most advanced and oftenly used text pre-processing techniques in almost every NLP project. So without further delay, let's get started and jump into the most advanced text pre-processing techniques. First technique is stemming, the process of converting a word into its root or base word. It is known as a stemming. So basically stemming reduces the word into its word stem, which means affix to suffix or a prefix. Let's understand with a simple example. For example, here we have word like playing and watch. So simply we want to convert these particular words into its root word. So here the root word of playing is play and the root or base word of watch is watch. So basically stemming convert a word into its root or base word. Stemming utilize basic rules to convert a word into their root words. For example, in English language, stemming removes some prefix or postfix like ing, ed, ly, tion, and etc. So basically, it will apply some basic rules like removing this particular prefix or suffix. Suppose the word like particularly, so it will remove ly and give a word particular, right? Suppose the word is utilization, so it will converted a word into utilize. Hope you getting the how stemming works. However, the most major disadvantage of stemming is for some word, stemming converts a word that does not have a meaningful meaning or a interpretations. Because as I have told, stemming just apply simple language rule. We don't have a prior knowledge of particular language while we use the stemming, right? It will just remove some of the prefix or suffix. For example, here we have a words like competency, so it generate or a convert a word compete, right? Suppose chocolate, so it give chocolate. Suppose at, so it will give at. So stemming does not have any kind of language knowledge. It doesn't know about the past tense, present tense, past participle of particular word. It just removed or it just apply some of the rules, basics rules, and give us a root word. Hope you're getting the how stemming works, right? So here you can see these words as doesn't make any sense, right? For this sum of the word, stemming does not give proper root or a base word to us, right? Now the second technique is lemmatization. So lemmatization overcomes stemming problem. It is also convert a word into root or a base word which has a meaningful meaning. However, lemmatization technique requires simple rules along with the prior knowledge of particular language, and also we can convert a word into verb or a noun or other forms of word based on our requirements. So lemmatization is very useful and oftenly used in many NLP projects as it gives proper meaningful word to us, right? Let's take an example of sentiment analysis. in which sentiment analysis we require, for example, adjectives, verbs in particular corpus or a paragraph. At that time, first of all, we need to identify adjectives and verbs, and after that we have to apply lemmatization to getting a root word of these particular adjectives, so that we can identify whether it is a negative words or a positive words, right? So at that time lemmatization is mostly, or stemming also apply based on our requirements, right? In English language, stemming uses all rules, vocabularies or variant of a word like a present tense, past participle, and etc. and etc. Right? Suppose you apply it in lemmatization, it will give a root word eat. Right? So basically, lemmatization is doing same thing like a stemming, but it convert that word into a meaningful word, basically understood by the human. I hope you got the idea about lemmatization and the difference between stemming and lemmatization. Now we directly jumped into the practical part of this technique. For applying stemming in our projects, we need to use NLTK library. We need to use nltk.stamp.porter and import porter stammer. There are many types of stemming algorithm. Here we have used the porter stammers, right? So then we need to make an object of porter stammer and store into stammer variable. So to convert a particular word into its root word, we use stammer.stamp. Suppose I have written a word chocolate, so it gives chocolate. For a competency, it gives compete. For a playing, it gives play. For a watch, it gives watch, and for a ed, it gives ed. Right? Hope you got the idea how stemming is used. Now, the second technique is lemmatization. To apply lemmatization or getting a word, root word of particular word, for that we need to import WordNet Lemmatizer by using nltk.stamp.wordnet. After that, we need to make an object of WordNet's Lemmatizer, and it is stored into Lemmatizer variable. To get a lemma means the root word. So lemmatizer.lemmatize and pass the word. Suppose here I have written running, so it gives running, right? So basically, if we want to a word, this particular word as a verb, so we need to apply the second argument v. V means v for verb, so it gives a root word run, right? Suppose here's the another example. Suppose the word is stripes. So if you have a requirement of this particular word into a verb form, so you just need to pass verb as a second argument, and if you have a requirement of as a noun, so you just need to pass n. So you will get the word is stripes, the verb form is stripe, and the noun form is stripe. I hope you get the idea how lemmatizer is used, right? Now, the third technique is tokenization. See, tokenization is nothing but splitting a word or a sentence and make a list of that particular corpus. It's work like a split function. Okay, so apply a tokenization technique. We need to import send_tokenize or word_tokenize into the our NLTK library. Suppose we have this particular corpus, so we have a requirement of sentence tokenization, so we just need to pass apply send_tokenize and that particular corpus. So you can see we got the list of sentences of this particular corpus, right? So it is very, very simple. So you can see here we have a two tokens, as we have a two sentence in this particular corpus. So we can check the length of this particular corpus. Now if you apply word tokenization for that, but in that particular corpus you will get all the words which is in the corpus, right? Okay, so if you have a requirement of word, then you can use the word tokenization, and if you have a requirement of sentence, then you can apply sentence tokenization, right? So tokenization is nothing but splitting a word or a sentence and give a list of that particular sentences or words for that particular corpus, right? Now the fourth technique is part of speech tagging. It is also very famously known as a POS technique, right? So POS technique is useful when you have a requirement of which word is useful for what in that particular sentence. Suppose, let's take an example. You just gave me a scale, right? So here you can see you is useful for PRP. You can see PRP means personal pronoun. For example, her, herself, him, himself, right? Here the second word just is used as a RB. RB means adverb, right? Likewise, gave is used as a VBD. VBD means word past tense, right? Scared is used as a NN. NN means noun or a singular, right? A is used as a DT. DT means determiner, right? POS technique is useful when you have a requirement like to extract all the verb or a noun or a determinant or a adverbs, right, in particular corpus or a sentence. At that time you can use these POS techniques and it is quite useful. So to apply a POS technique you need to use POS underscore tag in our analytical library, right? So here I have make a function called POS underscore tagging in which I have passed the text, right? First of all we need to apply word tokenization as we need a word to identify the part of speech for that particular word. So first of all we use the word tokenization and we get the list of words for the particular sentence or a corpus. After that we apply a POS tag and pass that particular list into the POS tag. So it will return a list along with the word and as well as how it is used in that particular sentence, right? Hope you got the idea why POS tagging is useful, right? Now the next technique is name entity recognition. Name entity recognition is useful when you have requirements like you need to identify person in this particular corpus or a sentence, or you need to identify organization in the corpus or a sentence, or you have a requirement to identify the countries name is used in a paragraph, corpus or a sentence. At that time you can use name entity recognition, right? So to apply a name entity recognition we need to use Spatial library. So install a Spatial library. You just need to use these three commands. After that you just need to import Spatial and you need to install Displacy. It is useful for a visualization purpose, right? So here I have used EN Core Web Medium model of Spatial. So to load the model we just need to use spatial.load and the name of the model, right, and store into NER. Here we have a text like Mark Zuckerberg is one of the founders of Facebook, a company from the United States, right, and just pass this text into NER in Spatial model, right, and we got the we stored the output into NER underscore text, right? So here we can see the objects of the text by using text.ents, right? To get the label of these words, we just pass this text.ent into a for loop, and for loop iterate each entity one by one, and we just need to print word.text. So it will display the name or entity, and the label, for the label we just need to apply word dot label underscore, right? So here we got Mark Zuckerberg is a person, Facebook is an organization, and the United States is GPE. So to know the explanation of GPE, we use spacey.explain GPE. Here we got the output. GPE implies countries, states, or a cities, right? Now to display this entities in a proper way, we use the displayNC.render, in which we need to pass ner underscore text, right? The output of ner, and we just use any style. Here I have used ent, so you can get this proper visualization. Here you can see Mark Zuckerberg is a person, Facebook is organization, and the United States is GPE. GPE means countries, cities, and states. Likewise, you can also know many things. Now, the next one is chunking. Chunking in NLP is a process to take small pieces of information and group them into large units. The primary use of chunking is making groups of noun phrases. The resulted group of words are called chunks. It is also known as a swallow parsing, right? Let's understand with an example. Here, to apply a chunky, we need to use text blob library, right? So here we just import text blob library, right? And then here we have a sentence like a black television and a white stove were bought from for the new apartment of John. So we just pass this text into a text block, and we got the result, right? So here A is TT, black is JJ. JJ means, you can see here, JJ means this NLTK pose tag is an adjective, right? So it's quite similar to the POS technique, right? But here we can also use to get the noun phrases, or we have some of the requirements like we want the verb phrases, right? At that time we just need to pass regular expression, or we can say is a pattern that we need to identify or retrieve in particular sentence or a corpus. Here you can see I want a noun phrase. So noun phrases is first one always be a DT means determinant. The second one is JJ. JJ means adjective, and the NN means noun, right? So I have make this kind of regular expression or a pattern and pass it into regex parser, which is in a NLTK library. So that's why I have import NLTK library, right? And store it into RP. So here we got the all the chunking part. You can see S means entire sentence. After that, it will check if this particular pattern is matched or not. Here we can see we got the noun phrase NP, because we have a black television in this sentence, right? A black television, right? So here you can see A means DT means determinant, black means JJ, and television means noun. So it is stored into this particular round bracket. After that we can see here and is allowed means CC. CC means conjunctions, right? After that we got another noun phrases, right? A white stove. Then we got verb bought as a verb, right? For as a in means preposition. After that we again get the noun phrases, the new apartment, and last of as a preprocessing as a preposition, and John as a noun. So here you can basically chunk entire sentence into particular pattern, or we can say as we have required. Suppose we have required noun phrases in particular sentence, or we have requirement verb phrases, right, or our custom pattern. At that time we can use this kind of chunking method to get that particular pattern or phrases in particular corpus, right? So here these techniques are quite oftenly used in NLP. So here these techniques are quite oftenly and most useful in any kind of NLP projects, right? Suppose as I have told before, uh, suppose we are doing a spread based sentiment analysis or a simple sentiment analysis. At the time we have a requirement of adjective, and the form of adjective should be a root word. So we can use lemmatization or we can say stemming. We can use any one of these technique, right? Suppose we have a requirement to extract noun phrases, verb phrases in particular corpus or a paragraph or our sentence. At a time we can use chunking methods, right? Or we can requirement of a noun extractor. We can requirement to extract nouns, verbs, right? At a time we can also use chunking, or we can also use POS, part of speech techniques also, right? And as name entity recognition, as we have seen that we have a requirement of identifying organization, cities, suppose a person, or we can say buildings, or we can say birds, right? Any kind of these kind of things we can identify by using name entity recognition, right? So this is all about the text preprocessing. Here we have almost seen 30 to 40 text preprocessing techniques in these two parts. So now in the next lecture we are going to learn about feature extraction techniques in NLP, which is most useful, which is very crucial part of any NLP projects. So stay tuned with us.